Okay, question 17, right? Now they asked this a few years ago and they could ask it again. They could find you a different way here of the derivative of cot x. Okay, now we know derivative of cot x is minus cos x squared x, okay? And we just proved that, okay? But they might ask you to prove it a different way, all right? So we're going to show you now this different way. So if you got that y equals cot x, right? And they say, look, write it as tan x to minus 1. Well, it is, isn't it? Because if you think about it, cot x is 1 over tan x, okay? So I take that tan x up. It is, isn't it? Tan x then, okay, you take it up, it becomes to the minus 1, won't it? Okay, it's not the inverse, you've got to be careful there. It's not like the inverse tan function, completely different that is, right? Inverse tan function is different to this. Here you're just taking the tan x up and the power is minus 1, okay? Anyway, so you've got this, and as we saw earlier on in one of the questions, when you've got your bracket power, it's a function of a function, so you differentiate the outside bracket first, okay? So you differentiate, you bring the minus 1 down, okay? Tan x then, and the power then becomes minus 2, because you take 1 away, and then you times by the derivative inside the bracket. And it says assuming the derivative of tan x, okay, we know that's x squared, don't we? Sec squared x, okay, it's in the form of the booklet as well, so you can use that because it says assuming it. So we end up with this, okay. Now what I would do next is rewrite this as minus then 1 over tan squared x, okay, times sec squared x. I'm doing that because it's minus power 2 here, so take it down, okay. The other thing then you can do is realize, well, okay, now in this case now I could rewrite this as, well, tan squared x on the bottom here is the same as sine squared x over cos squared x. Yeah, that's what I could do there, because that's what tan squared is. Well, tan is sine over cos, so tan squared is sine squared over cos squared, times then sec squared. I could rewrite sec squared as 1 over cos squared, couldn't I? Okay, that's what sec squared is, 1 over cos squared. And then of course this fraction then can flip, okay, so that cos can go up to the top. And you notice then, cos squared's cancelled, don't they? That cos squared cancels with that, and you end up having minus 1 over sine squared x, which is minus cosec squared x, which is exactly what we want to prove, okay? So watch that again, just to get the idea, but it is really straightforward when you get the hang of it.